I'm going to focus on how to get the equation of a line in 3D. And that'll be my goal. And then we'll see how much time after that we have to look at how to get the equation of a plane in 3D. So this fella here is essentially what you need. If you want to find the equation of a line, tell me just two things. Tell me a point on the line and tell me the direction vector. And if we call the point x naught, y naught, z naught, and the direction vector ABC, then the vector equation of the line is like this. If you want to write it down in its parametric form, you essentially write it down as three equations. Okay, that's kind of where we were last time. So we're going to look at different ways in which you could be asked to find the equation of a line. And by that, I mean different information that they're going to give you. So they could give you, it passes through the point 1, 2, 3, and its direction vector is 1, 5, negative 1. Now, if they gave you that, aren't you basically good to go? You don't need to do much. Everything you need is here. This is the x naught, the y naught, and the z naught, and this is the ABC. I'm going to do the vector equation format for the equation of a line just because it's a little bit easier. It's 1 plus 1t, 2 plus 5t, and finally 3 take away t. Would you agree that's pretty straightforward, right? So if you tell me a point and the direction vector, so this is basically question 2 is like that, then that's what you do. Okay. Now, suppose I tell you the coordinates of a point P and another point Q, and I want to find the equation of the line that passes through those 2 points, then my goal is the same as it's always going to be. My goal is to find a point on the line and to find the direction vector. Well, in this case, I'm going to pick this guy here as my point. And how will I get the direction vector? All I know is it passes through P and Q. How will I get the
Q from P or
yeah,
P from Q?
Whatever way you want to say it. Find the vector PQ. Great. And 3 take away 1, negative 1 take away 5, and 5 take away 1. And I can now do the equation of the line. X naught plus 2t, y naught minus 6t, z naught plus 4t. So if I know a point and I know the direction vector, don't I know the equation of the line? Now, we spoke yesterday about the fact that these equations are not unique. To give an example, suppose I decided to use Q as my point. Won't these numbers turn into 3, negative 1, and 5? And so I'd end up with a different equation. Suppose, because I just felt like it, I did the direction QP. Then wouldn't the vector be negative 2 plus 6 and negative 4, which means these would change sign. So the fact that the answer is not unique might make it a little bit tricky for WebAssign. I'm hoping WebAssign writes down every permutation that you might use in a certain circumstance. Because I could imagine a situation where, couldn't you have the equation of the line correct? It just doesn't happen to be one of its equations of the line. Can you imagine you went one way and they used the information in a different way? We good? Now, how about this one? This is going to be similar to question 3. Suppose I tell you a point on the line, a coordinate 0, 1, -5, and I tell you this, that my line is parallel to the line, and the equation of the line that they gave me in its parametric form is this guy. So all I know is that my line passes through this point and it's parallel to that one. So can you imagine that that's the line they're talking about? And my guy's up here and my guy is parallel to it, right? So I need one piece of information that's missing. Don't I need to know what direction my line is going to be in, right? I need my direction vector. How can I use this guy here to get a direction vector?
The coefficients on the t's?
So 4, -2, 8. If you think about it, isn't the coefficient on the t's the direction vector? Does that make sense? The coefficient on the t's. So this line has a direction 4, -2, 8. My line's parallel to it, so 4, -2, 8. Now you put that together and I've got my answer. The equation of the line, again for speed I'm putting it in its vector form, would be 0, which I guess you don't write, 4t, a 1 take away 2t, and a -5 plus 8t. Are we comfortable with that process? That if I tell you a point on the line and that it's parallel to something, another line, that we can get the direction of our line by using the coefficients of the t's. Have we any problems with that? Okay, I'll move on. This guy that I did here, it's like question 6 and it's like question 5. I just noticed that as I'm scrolling through the questions. Mm-hmm. Okay. I think that's all I need to do right now on finding the equations of lines. I'm going to be doing other examples, but right now that's as far as I'm going to go. And now we're going to look at how to find the equation of a plane. Right up here. The equation of a plane that passes through the point P, x naught, y naught, z naught, with a special guy called a normal vector n, which I'm going to call A, B, and C again. Now, this is not a direction vector. This is a different kind of vector. It's called the normal vector, but I'm going to use A, B, and C for the components. Well, I guess I could use L, M, and N. A, B, and C will do. Is AX plus BY plus ZZ is equal to AX naught plus BY naught plus CZ naught. So the equation of a plane that passes through a given point P with a normal vector called ABC is given this. So let me try and show you what that looks like. First, when we talk about a plane, what we really mean in 3D world is a flat piece of paper bent at an angle. So can you imagine all the points on this piece of paper would be called a plane. In fact, not just this piece of paper, but can you imagine it moving in all directions forever, right? A flat surface. That's what a plane looks like. Can you imagine that on this plane, there is a point called X naught, Y naught, Z naught? The guy that is called the normal vector is a vector that is perpendicular to the plane. So what would that look like? Here's a cardboard, that way it doesn't flop, right? See this guy here? So there's my P, X naught, Y naught. This pen is the normal vector. If I orientate it differently, I don't know, I'm just trying to do a camera here. This way. Can you see it's at normal? If I bend it a little bit, can you see what I'm talking about? Can you see that the normal vector is zooming away from the plane, but it's doing it in such a way that it makes a right angle with the plane? That's what a normal looks like, right? A direction vector would be like that, right? It would be in the plane, right? That's not the same thing. So if you take, if you want to find the equation of a plane, essentially you need two things, very similar things to a line. Don't you need a point and a direction? For a line, it's a point and a direction vector. And for the equation of a plane, it's a point and its normal vector. So let's give you some examples of how that might work. Suppose I have the point 1, 2, -3, and you tell me that the normal vector, this guy here, is 1, 5, -2. Then this guy is my X naught, my Y naught, and my Z naught, and this is going to be my A, my B, and my C. So what do you get? You get AX plus BY plus CZ is AX naught plus BY naught plus CZ naught. And A is 1, so you get 1 times X plus 5 times Y minus 2 times Z is 1 times 1 plus 5 times 2 plus 2 times plus -2 times -3. So I get X plus 5Y, take away 2Z. 1, 10 is 11, 11 add 6 is 17. There is the equation of the plane. Now the equation of the plane is a linear combination of X, Y's, and Z's. So if you ever see a surface in 3D and they tell you its equation, and it's made up of linear combination of X, Y, and Z, you are looking at a flat piece of paper, right? A plane, as we call it in 3D. Kind of cool? Let me give you a plane and just do something with it, which is sometimes done by people before 3D software was invented. If I had 2x plus 3y minus 4z equals 24. Right, I know that's the equation of a plane. Wouldn't it be helpful if I could find out where this plane cut the X, the Y, and the Z axis? Right, wouldn't that be nice to know? Right, if you want to know when it cuts the X axis, Y and Z are both 0, so it cuts it at 12. If you want to know where it cuts the Y axis, X and Z will be 0, and that gives me a Y of 8. And if you want to know where it cuts the Z axis, X and Y will be 0, and that gives me a Z of -6. Now, if you join this together, do you see that you make a little kind of triangle-y thing? Isn't that triangle basically drawn inside the plane? Doesn't it give you a slight orientation of what that darn plane looks like? Now, if you go to GeoGebra and you want to do the equation of a plane, okay, let's go for it. It might or might not work the way I want it to, but that's fine. Give me a few minutes to load it up.
I did figure out how to make it do the sine curve.
Oh, from that earlier issue that we had?
Yeah,
What was it? What did you need to
you
do?
have to have it z equals that sine of x.
Ah, so this is going to be the same problem then. I'm going to type in what the thing looks like. Well, I'll try it the way I want it to work, and then I'll do the z equals if it doesn't. Go figure. Okay. Let me show you what that equation looks like if we use GeoGebra. And guess what? It works. Evidently not for everything, but it works for this one. So that's kind of cool. If I type in another plane, I'm just making this guy up, x plus y minus 2z equals 9. And I hit a little enter on that. I have another plane. Oh, that's interesting. Let's make this bigger. Now that should orientate it a little bit better. Good. I should be able to change its color, shouldn't I? Let's make it something a little bit more noticeable. How about red? There we go. So here are two planes. Now, if you see these two planes, oh, by the way, this gray thing is the XY plane, right? But the two planes we're talking about are these two. You see the blue and the kind of pinky one? And the blue one is the one that we've got, and the pink one is the other one. Right. And probably I could have done better examples, but can't you plug it in and see what it looks like? And that's the gist of it. So let's return now back to the math of it, of how do you get equations of planes? Well, if you tell me the point and you tell me the normal, I'm good to go, aren't I? Right? I can just plug them in. So what are they going to do to make your life a little bit more awkward than that? Well, they're going to give you information that allows you to get the plane. It's just not going to be in a format that you would want. But let's start back up a little bit. This is an example of question 11. The point is that, and the normal vector is written as 9i plus a j minus a k. Of course, you know me, I write it like that. It's the same thing. Now, since you have told me the point and you have told me the normal, don't I just say 9x plus 1y take away z is 9 times 7 plus 1 times 6 plus -1 times 1. And there is the equation of the plane, almost with no work. 63, 69, I believe it is 63, 69. I believe it's 68. An example of that is question 11. Now, question 12 gives us a point. This time the point on the plane is that one, but they don't tell me n. Instead, they say it's perpendicular to, lost the damn thing. Perpendicular to the line. Scanning's not good here. 5x, 9 minus t, and z equals 5 plus 4t. Now, can you imagine that this is the plane that I'm trying to get the equation of? And can you imagine there's p? Now, I need to know the normal vector, right? They have told me that my plane is perpendicular to this line. If my plane is perpendicular to this line, doesn't that mean that my normal is 5, -1, 4? Do you see they've just hidden it in the way that they phrased it? If your plane is perpendicular to a line, isn't the direction of that line a normal to the plane? Does that make sense, the logic of what I just used there? My plane is perpendicular to that line. This line has slope 5, -1, 4, so my normal would be that. Can you double a normal? Can you do 10, -2, 8 if you felt like it? Yeah. Doesn't that make the equation of a plane non-unique as well now? So just find any normal that works. So in this particular case, then that would be my A, B, and C. So I would have 5x, take away a y, plus 4z. This would be my x naught, y naught, z naught guy. And so 5 lots of 1 plus 0 lots of -1 plus 4 lots of 3. And so the equation would be this guy. 5, nothing, 5 and 12, I think it's 17. Okay. Here is I think there's 2 of these. Let me double check before I tell you something. Right, okay. I want the equation of a plane that passes through three points. Can you imagine this is P, this is Q, and this is R, and we'll make the assumption that it's not coplanar, right? Well, actually, we will make the assumption that they belong inside a plane. So I want to find the equation of this plane using the points P, Q, and R. Now, I need 2 pieces of information. Don't I need a point? Well, I might as well use that one, right? Use the first one they give you as your point. Would you agree that P is on the plane? Now we got a problem. Don't I need to find a normal? And I need a strategy for finding that normal. How do you think I'm going to do it? All I got to work with is this triangle, PQR. Last few seconds. It's better if you find it out yourself. Say again?
Cross product.
I agree. Who am I going to cross product?
PQ and PR.
Does that make sense? That if you find PQ and PR, what will the cross product give you? Won't it give you a guy that's at right angles to PQ and PR? And isn't that what a normal is, right? It's at right angles to those two guys. Haven't we found another use for finding cross products? They allow us to get the normals of planes. Now, in this particular question, PQ, 1 take away 0, 0 take away 1, 1 take away 0. PR, 1 take away 0, 1 take away 1, 0 take away that one. Oh, these are really quite nice vectors. So let's find out what we get. It's going to be an I, a J, and a K. And 1, -1, 0, and 1, 0, -1. That's so many I's. Take away so many J's, plus so many K's. So we can get 1 take away nothing, -1 take away nothing, and 1 take away, no, nothing, take away -1. And so we get, as a normal, 1, 1, 1. Oh, kind of boring. So that's my ABC. And there's my point. So the equation is going to be x add y add z equals 1 nothings plus 1 times 1 plus 1 times 1. And the equation then is x plus y plus z equals 2. Now, couldn't we have turned these numbers into 7, 9, 11, and 42 and big, ugly things? But wouldn't the process be the same? You just find PQ, you'd find PR. The cross product of those two vectors would be my normal. Once I know the normal and I've got a point, we are good to go, aren't we? Tell me a point, tell me a normal. I'm going to get you the equation of a plane. That particular question was like 13. Any questions? Are we good? Although we're finding different things, isn't the processes kind of similar? You know, give me a point, give me a vector, plug it into an equation. One will get you a line, the other will get you a plane. So what we're going to look at now is interconnection between lines and planes. So there's all sorts of different kinds of combinations of lines and plane questions. Let's do, how do you find the intersection of a line with a plane? Let's look at a question that does that. Imagine that I've got a line and its equation is this fella here. And I have a plane. Who's that guy? Visually, I can imagine here is my plane, this is the line. Would you agree that they intersect? If they're going to intersect at all, would you agree that they intersect at a point? Right? Wouldn't a line, like a bullet shooting through a piece of paper, wouldn't it make one hole on its straight journey? We would like to find the coordinates of that point of intersection, right? Which I guess I'll call P because I like P. Any ideas about how we can use these two pieces of information to solve that problem? Little clue. Isn't this the x coordinate of the point on the line? This is its y coordinate of a point on the line. And isn't this the z coordinate of a point on the line? How could that help us?
Do we plug them in instead of the x, y, and z in the equation?
Yes. So I'm going to substitute these guys in here. So instead of x, it's going to be 1 plus 2t. Instead of y, it's going to be 3 plus t. And instead of 3z, it's going to be 3 lots of -1 take away t. And because it's on the plane, it's equal to 10. Essentially substitution, really, aren't I? Now, I'm going to have an equation in t, but that's okay, because can't you solve an equation if there's only one variable? And so what I'm going to get is 1 plus 2t, add a 3, add a t, take away a 3, oh, shooting space. Can I change that guy to 2t? No, actually, take it back. Do I? Yeah, put it back in, 2t. So I end up with -6t equals 10. Okay, so what do I get? 1, 3, 3, I get 1. That guy there, that's good. And now I can subtract 1 from both sides, and I get t is what, -3? Oh, do you know why I had to change that question?
You
Because all
ended
my
up zeroing t's.
yeah, that's not a good idea, right? But I'll come back to that after we've done this. I haven't got the answer yet, but I'm darn close to it. Can't I just plug 3 into the equation of the line, and that'll tell me where it is? It's at 1 plus 2 lots of 3, which is 7. 3 plus, no, it's not, it's -3. It's 1 plus -6, so 1 take away 6, it's -5, 0, and -1 take away 2t ends up being 5. So it ends up being that point there. Now, I know that's a vector, but it's also called a position vector, which means if you imagine it being at the origin, you would end up at the point with coordinates -5, 6, 5. So -5, 6, 5. This might be. Right, back to that guy. If the t's disappear on you, right, because it could have happened, what on earth is happening? Well, one of two things are happening. Couldn't my line be in the plane? In other words, drawn on the plane. The other possibility is, couldn't my line be flying above, i.e. parallel to the plane? Now, if the t's disappear on you, two things can happen. When they disappear, you get 10 equals 10. Or when they disappear, you get some other number equals 10. If you get 10 equals 10, you are looking at the line is in the plane. Right, because what that means is, it doesn't matter what value of t you pick, is going to work, right? Because 10 equals 10 is true all the time. Now, isn't 20 never 10? So what would that be? That would be this situation here. So you could, that process would still work. It would just tell you, oh, that line doesn't actually really intersect the plane. It flies above the plane, or it's embedded in the plane. So they're the three, I guess, situations that could happen. Are we good with the question?
Yeah, shouldn't be R -3 equal -504?
Oh, let me check if I can't count. -5, check, that is a 0. And -1, take away 2 lots of that, the 5 is okay, but the middle should be 0. I changed that question to be that guy. So it's -1 add 6, which is +5. Let me tell me what a question that looked like that is like. Yeah, the one that we just did, for instance, question 14 is a similar kind of situation. Okay, we got 10 minutes. What can I do next? Oh, let's look at two lines together. Right? We've looked at what happens if a line and a plane intersect. I want you to imagine I've got two different lines. I'll call them L1 and L2. Right. Let me draw that again because I don't want that. Two lines in 3D space. If they do intersect, won't they intersect at a point? Agreed? Two lines could also miss each other entirely. It's a bit hard to do this in 2D, but if you imagine these two pens, you see that they're flying above each other. They'll never meet. These are called skew. So two lines that look like that, right, but never meet are called skew. Two lines that meet at a point, right, they cross. Not surprisingly, we call this situation an intersection. And the third possibility, which is one I kind of drew right at the start, is couldn't the two lines not meet, but couldn't they be parallel to each other and not meet? So although they do not meet, there are two versions of that. Can you imagine, put a little dotted line to try and indicate separation here, right? That when they meet, or when they fail to meet, that's skewed. If they fail to meet because they're parallel, we call it parallel. So you're going to get a question, actually, you might get more than one, where they give you the equation of two lines, and you're being asked, let me find an example of that, question 9, which is decide whether these two lines are parallel, intersect, or skew, and if they intersect, find the point of intersection. Okay, so you're going to be given the equation of two lines, and you're going to find out which one of these three situations it is. And if it happens to be the top situation, you're also going to find the point where they intersect. And if it's these two, then the question's over with. So the first one, line 1, is called x equals 1 take away 6t, y is 6 plus 12t, and z equals 5 take away 9t. This is going to be my last question for today because we have other things to talk about. And the second line is going to be this. Have you noticed that the second equation doesn't use the same variable as the first one? There's good reasons for that. These two lines are totally independent of each other. So the dummy variable, which is what we call t, should be different in each case. Now, I don't know if I'm going to get parallel, intersection, or skewed, but I have to figure out which of those is happening. Okay, so how do we do it? Well, I'm going to call these equations 1, 2, and 3. I'm going to call these equations 1, 2, and 3. And I am going to solve this problem by tackling it with a technique that you used called systems of equations. So I'm going to match equation 1 in both the lines. So I have got 1 take away 6t is 6 plus 4s. In other words, I'm matching this x with that x. And then I'm going to take equation 2's and match them, right? Match the y's. And when I do that, I get 6 plus 12t, and I have negative 8s. So what we're looking at here, it's a little bit ugly, but is it not a system of equations from Math 94? Now I'm going to make it slightly pretty because to me it helps. So I'm going to, what should I do? S. I'm going to subtract 4s from both sides. I'm going to subtract 1 from both sides, so that's my new equation 1. And add 8s to both sides. And subtract 6 from both sides. And I get that. And all I'm doing here is getting them so that the two variables are together, right? Can you remember the technique that you can use to solve systems of equations? How I would solve this system of equations?
Substitution.
Yeah, sometimes called the substitution method. That's right. And what's the other one called? And I'm not saying the substitution method won't work, because it will, it's just ugly. But what's the other? Addition method. Now, in the addition method, don't you have to make one of them double, or one the same as the other, but a plus and a minus? So can you imagine that I multiplied this equation by 2, essentially doubling everybody, and I leave the other equation alone? So there's my new equation 1 and 2. If you now add these equations together, the variables disappeared on us. Agreed? Now, what on earth must be happening for this to occur? Well, would you agree that 0 equals 4 means that there is no solution possible? So we're left with they are skewed or they are parallel. That's all I know. It's either the two lines are skewed or they are parallel. Agreed? Now, if you look at equation for line 1, isn't its direction vector -6, 12, -9? If you look at the second line, isn't its direction vector 4, -8, 6? Now, if these two lines are parallel, won't these direction vectors be multiples of each other? And if they are multiples of each other, we have a parallel. If they are not multiples of each other, then we have skewed. So what you do now is you look at the direction vectors. Now, the easiest way to check is just to take each component and divide them. Do you notice that that's a -3/2 every time? Does it not make one of those a multiple of the other? And since that's true, the lines are parallel. Suppose I did this division thing, and I got -3/2, -3/2, and 5. Then this would mean they are not multiples of each other. And if that had happened, so let's pretend it did, then we would say skewed. So that's how you tell the difference. Now, let's wind back. Let's pretend for a minute that this didn't disappear on us. Let's suppose, 4s equals 4 halved, right? Then wouldn't we know what s is? Wouldn't s be 1? And if I know what s is, shouldn't I be able to find out where they intersect? Right, if I know s is 1. Now, that should be true, but you have to do a check. You plug S equals 1 and you'll get a coordinate. You should be able to solve this and find out who T is then. Maybe T is 5. You plug T equals 5 in. If this guy says 1, 2, 3, and this guy says 1, 2, 3, aren't you looking at a point of intersection? If this guy says 1, 2, 3, but this guy says something different, guess what's happened? They're skewed again. The first one doesn't match the second. So they're flying above each other, right? So they share some coordinates, but they don't share at least one of them, in which case it's probably going to be, you'll get a 1, 2, 3 and like a 1, 2, 8, right? One will be at 3 and the other will be above it at 8. So that is the entire combination of intersect, parallel, or skew. You try and solve the system of equations, and depending on what happens. So to recap, if that happens, parallel or skew, you then check to see if it's a multiple. If they are multiples, parallel. If they're not, skewed. If you get a solution like S equals 1, T equals 4, right? You get a solution. You check it against these two guys. If the coordinates match, you've got an intersection. If the coordinates do not match, you've got skewed. So do you see how skewed could be hidden in two different ways? It could be hidden in the 0 equals 4 situation, but couldn't it also be hidden in the solution S equals 1, S equals 4 situation? So the skewed is a sneaky bugger because it could happen in more than one way. And that is perfect timing. We are going to, I'm going to have to reduce a couple of questions that we never got to. It's not fair to give you questions that we haven't at least covered, but your test is going to be up to and including this one. I'm going to extend the homework to midnight Monday, since Monday's a holiday. Everything else is pretty much as usual, right? So you know you've done 2 tests, so it shouldn't be a surprise how I'm going to do the third one. If you have any issues, just do the usual, shoot me an email and we'll try and arrange a Zoom meeting, or I'll try and answer it other ways. Kathy, did I finally fix that problem? I can't hear you.
I could see my test, but I'm not sure. I haven't looked at it yet to see if I could see what I got wrong.
I've hopefully fixed that second feature.
Okay.
Right, but I'll keep trying. There's all sorts of menus inside menus I have to work with. Okay, so are you all comfortable? You know what's in the test coming? Right,
So
pretty much.
the next test will have this that we just did?
It will have this stuff in it, but only the stuff we've covered. Once we finish, I'm going to go back in and take out some questions that we never got over. We never had time to go over. So you're only going to see stuff that we've covered in class today, but it is going to be from this section, right? So you're going to get equations of lines, equations of planes, and a few other intersections and things like that.
So we won't get anything from applications of Taylor's?
That's not what he meant.
No, that's not what I meant.
Are we getting them?
Yeah, we covered that. Applications was, finding the maximum error that you would get using a T3, right? That kind of thing. That was what the applications was. We covered that. No, I'm just talking about this section here. I'll give you a number as soon as it scrolls up. Oh God, my mouse has went weird on me. Here we go. We are going to do in your test everything from where we finished off last time up to and including 12.5, which is lines and planes. So anybody know off the top of their head where we started 2 weeks ago? What was the section? I think it's going to be applications of Taylor's. We didn't have that in the test. So application and Taylor's up to 12.5. What I was talking about is there are going to be some questions from 12.5 that I'm going to take out. because we never covered them. But the rest are going to stay. Does that make sense? Okay, it makes sense. Right, I'm going to hang about for any other questions. You're not allowed to have a good weekend, by the way. You can have 2 hours during Valentine's Day, right? Maximum, just 2 hours. And then the rest of your weekend has to be miserable because you're getting ready for your test and you want to do good. Okay, bye-bye, everybody.
Thank you.
You're welcome.
I do have a question, Professor. This might be beyond the scope if we're going to do it in the future, but I'm curious about how you might model in 3 dimensions or come off because we're talking about the line equation in 3 dimensions.
Yeah, and the plane.
How you might model say a curve, like a part of a sphere, if that makes sense.
Yeah, or something traveling along the surface of a sphere.
Right, yeah, exactly.
There are shapes called helixes, which you start and you circle up and then you circle down, right? We will do those. They'll be called space curves.
Okay, cool. Yeah, if we're doing them in the future, that's all I need to know.
If you want to look, just because you're curious, helixes is one of the names for those spiral shapes. But space curve is its general title. It's quite, you actually kind of sort of know it. Do you know the vector equation R of t of a straight line? Space curve's the same thing, but they will look like this. R of t is 5 cosine t, comma 2 sine t, comma 2t. That would generate a space curve. In fact, it would spiral upwards.
Okay. Yeah,
but I mean, you plug anything you like in for X, Y, and Z, and you can make some really cool. You could model a jet flying in 2D, flying in 3D space, which was zigging and zagging and looping the loop and coming back on itself and doing figure eights. Anything you want, you could actually model that in 3D using a space curve.
And this might be more of a physics question, but how would you say you got the sphere, right? The surface, I guess, the surface area,
or a thing traveling on the surface. Yeah.
Well, even say it was if we had vectors opposing each other at not diametric angles, say like like stress, for instance, like if you say let's talk about like a metal, for instance. If you had 2 metals pushing against each other at different angles,
okay, they would be vectors.
Exactly, like so vectors. Like, how would you model that in the shape of a sphere, I guess?
Well, you wouldn't model it because it'd only be 2 single vectors. So you could do it just by a 3D vector being added to a second 3D vector, and the resultant force would be the accumulation of adding those two. Now, if you had an entire sphere, and on that sphere there was lots of different vectors pushing on it, you'd need to go into Calc 4, where you do triple integrals and talk about vector calculus. But that is modeled, if that's what you're trying to do, that would be modeled in Calc 4, not in Calc 3.
I guess that was kind of my question, because and it's a good conversation for us because like since I'm going into earth sciences, we're doing a lot of seismology, so I'm curious about how different faults and fractures occur right in the earth, right? So
right, I think the way they have to do those ones is more numerical based. They have general models, like you have general climate models, but there is so many variations in them that a lot of the time weather is based on, in a similar circumstance, what happened, and they use that as a kind of starting point, and then they tweak it a little bit. It says, well, it's not quite the same temperature and not quite the same wind. So if I was looking at a shift between 2 plates, for instance, I mean, there's so many things that affect that, not just the forces, but what's the material. I mean, if those 2 things are rock, it ain't going to be the same if it was limestone, right? Granite, I'm saying, right? Granite, limestone, different effect. Same forces, but one might share a lot and the other might not share at all. So there are so many factors in it that they tend to, their modeling is not a single formula in calc. It's more lots of formulas plugged into a computer, because they're the only guys that can handle the complexity of all these interacting forces. And then they say to the computer, model this and tell me what you think is going to happen. Because if you notice when they do weather, there's actually more than one weather model. When they do a prediction on where a tornado, not a tornado, whatever it is, a cyclone, whatever you call the damn thing's a hurricane, right? Where a hurricane is going to hit the thing, they'll have model A, B, and C. And model A says, we believe it's going to go this way, model B is this way, and model C is the way. The reason they have three models is that they're plugging into a computer starting information with predictor information of what they think is likely to happen in the near future. And if you make different adjustments to that, the model says, oh, it swings off. Now, if all three models kind of go in the same direction, you've got a good forecast. But sometimes model A says it shoots off north and doesn't even bother anybody. And model C says it heads straight for, you know, Houston or something, right? So yeah, good models get a success rate. And if they're good at predicting the truth, they get better weighting the next time they use them. And if they're really bad at doing the prediction, because you know what happened after the event, then they get lowered down on there. And there's lots of models that have been kicked out that we don't know about because they were useless, or they get adapted beyond what they started life off as. So I bet you they've got the same in the life sciences when they do earthquakes and you know, how big's an earthquake going to be? I believe, for instance, don't they take into account volcanic activity as well? In some places, if there's volcanoes near, that's a good indication bad things are going to happen. And another one they do a lot of information on in their models is baby earthquakes that you don't even know, micro earthquakes, because very often they're an indication is something happening. And you can sometimes predict earthquakes because you've got a good model of what most earthquakes are like. They don't normally just boom. There's normally a little warning before the boom part happens.
Yeah, the foreshadow. And part of the reason I'm taking a class, it's the class is just called like natural disasters, right? And we're actually looking at the greater Puget Sound area, you know, the Seattle area, for faults, right?
What do you want?
What's that?
No. Can I wait till I sell my house before we're due one? I'm retiring in under 5 years. Can it just hold off to 5 years and 1 month? Right? That's all I'm asking. Right?
Well, I think you'll be all right. I think you'll be all right for any major, especially in Bremerton. Yeah, any major thing. And you know, the high rises in Seattle, well,
Not
at least
so
the old
sure.
ones. Yeah, whatever. But a house in Bremerton's probably gonna be all right.
Okay.
But no, I ask because we are studying it, and it's interesting to think about how the rock is formed, and that's why I'm asking about the space curves, as they're called, I guess.
Yeah.
And how it's formed and how it's broken, because obviously a rigid material emerging from the planet cannot naturally form a sphere, right? So it's the gravity that breaks it, and that's how you get the faults, and that's how you get the movement, and subsequently the earthquakes, I guess.
Well, it's an interesting branch of science, and you'll have lots of fun learning stuff I don't even know about. I'm very good at talking about things I don't know anything about, but it's one of my many weaknesses. I know a little bit about a lot of things, but not an awful lot of things about, well, maybe a lot of, you know, maybe math is one exception. I know a fair amount about, but most other things I don't know an awful lot about.
Well,
Okay,
math is the foundation of science, so
it is. Okay, we got some homework questions or general questions. Kathy, has that thing worked? Is that what you're about to tell me?
I was going to tell you that I can see my score, but the View My Class Insights still has that other student's information in it.
I have no idea how that happened. So when you say view my insights, you get the other student stuff, but you don't get yours. Yours was separate. Would you do yours at the same time as the rest of us, didn't you?
I did at the same time as the rest of us.
So yours should just be in there.
My general stuff is in here, I believe, because it has that other student's name attached to test 2 information.
I have no idea what WebAssign did that for. I mean, I could just kill that, but that would stop her from being able to looking at her stuff.
Yeah.
But if I killed her, would that stop you from finding out what you wanted to know?
I'm able to see my test and what I got wrong on it now.
Right.
It's just if I go into my class insights, I'm seeing that other student's information, and that makes me uncomfortable.
I hear you. I'll kill her information if that makes it better, and she can just go. She did really well, so I don't think she's too worried about that one anyway.
Okay.
Yeah. Okay. So I'll note to self to kill that homework. But actually, I'll just remove it from sight. That's what I'll do. It'll still exist, but nobody will see it.
Yeah. Okay.
Homework questions. You're welcome. Homework questions, guys. What you got? Or do we have any homework questions? That floating dog of yours, Sam, is just freaking me out.
Yeah, he freaks us all out sometimes.
Okay, right back to the question. What have we got? Douglas, you got a homework question.
Yeah, could we do another example of the trying to find the lines that are parallel, skew, or
Okay, so 2 straight lines, and what did they do? Right, let's find a question that they've
or like
got.
could you just explain like the difference in how we find the line with a plane, and if they intersect or if they don't, with
Sure.
a line and a line?
Right, just show you the visual differences. The math will be a little bit different because of different information.
Yeah.
But if you did a plane and a line, then this would be intersection. The line hits the plane and goes on its merry way. And in that type of question, you find the coordinates of the point P, right? And I'm just pretending I found it. You could have a line and a plane, but in this case, the line is embedded in the plane. In that case, there's no unique intersection. What I mean by that is all the points on the line are also on the plane.
So that's like the line having like multiples.
Yeah, any one of these guys would work. Now, what would that look like? When you try and solve the equation, you end up with things like 10 equals 10 or 0 equals 0. The variable, the letter, the t will disappear. But what's left behind will be equal to each other, right? 10 equals 10 or 0 equals 0, whatever it happens to be. That's what that would look like. Up here, if this happened, you would get a t value, let's say 3. And then when you plug it in, you'll be able to find the coordinates. So you try and solve the equation. Now, you solve them by substituting the x, y, and z in the equation of the plane by the 4 plus 2t, whatever it is, from the line, and you solve. Now, the third possibility is that the line never, ever intersects the plane. It flies above it. In this case, what you're looking at is essentially that there is no solution. And what does that look like? Well, you try and solve the equation and the t's disappear, but you're left with something that's not true, right? 10 equals 7, 0 equals 42. And when that happens, you know you're looking at this third situation. There is no solution. if the t's disappear, but the bit that's left behind are equal to each other, you're looking at no unique solution because the line is embedded in the plane. And then the one you want is you get a value of t and it works. So that's the combination for a line and a plane.
So would the no solution, is that called a skew, or is skew only for lines?
Skew's only used for lines.
Okay.
Now, you could have two lines intersecting at a point P, in which case you solve using the system of equations. And when you solve, you get something like that. And when you plug it in, both formula tell you the same point. Right, so you take equation 1 of each and you match it with equation 2 of each, and you solve the system of equations, doing the algebra method, and eventually you find a t and an s. Right, you solve it. It's solvable. Right. You then find the coordinates that each one is pointing to. If they agree, it's because they intersect. So that's what intersect looks like.
So
Now, yeah.
So you use the system of equations, and then you find the points for two of the lines, and then if they're equal, then they intersect, and if they don't, then they're skew or parallel.
Correct.
Okay.
So this is my kind of trying to show you a skewed, right? They don't actually cross. You still get a solution, because this can happen. And you plug them in, but they don't agree. And that's what skewed looks like. Now, you try and solve the equation, right? And the t's disappear, or the s's, whatever it is, and you're just left with some numbers that won't be equal to each other, right? 10 equals 5. Now, that could happen two ways. It could be because the two lines are parallel, but it can also happen because the two lines are skewed. So what you know right now is when this happens, you know one thing for sure. You know they don't intersect. What you don't know yet is which of these two is the reason that they don't intersect. And what you do then is you get the direction vector of both lines. And if the direction vectors are multiples of each other, right, then you are looking at parallel. If they're not multiples of each other, then you are looking at skewed. Now, how do you know if two vectors are multiples of each other? Divide the x components, divide their corresponding y values, divide their corresponding z values. If you get the same number each time, they are multiples of each other, and so they are parallel. If you do the divisions and they are not multiples of each other, right, the ratios are different each time, or at least two of them are different, then you are looking at skewed.
Okay.